Under its visionary leadership, Egypt has embarked in a series of projects aiming at the reclamation of millions of fedans in the Western Desert, to transform them into agricultural lands. In the last 2 decades, a series of projects supported this long-term vision. The Toshka project pumps water from Lake Nasser to be transported by way of a canal through the valley, with the objective of transforming 588,000 fedans of desert into agricultural land. Since 1999, 50,000 fedans have been developed. Al-Farafra in Egypt's southwest, the reclamation of 10,000 fedans was declared by President al-Sisi, marking the first stage of the project plan to add 1.5 million fedans to the country's 8 million fedan farmland. The East Owaynot project, visible from space, cultivates 100,000 fedans. On the March 20, 2018, the visionary project imagined by His Excellency President Abdel Fattah el-Sisi has been inaugurated. The project aims at the reclamation and cultivation of 1 million fedans along Maywar ad-Dabha. The implementation is entrusted to the youth of Egypt, the Egypt Air Force. In less than 12 months, thanks to the leadership and focus from the Air Force commanders, the project team managed the well drilling, installation of pivot irrigation systems, electrification, and cultivation of 3. The reclamation and cultivation of the 1 million fedans is now within reach, with a future farm projection of 4 million fedans. What about the water resources? The estimated water demand for the 1 million fedan project is in the order of 17 million cubic meters per day. Numerous studies conducted by top research scientists in Egypt all concluded that the sustainable yield of Al Mogra aquifer should not exceed 500,000 cubic meters per day. The shortfall in supply will be sourced from the Nile River through Al Karama, the Future of Egypt irrigation canal. The project will tap into Anasiri and El Bohari canals, convey the water through a headrace canal over 1,500 meters to the west. A gigantic pumping station will lift the water from the level of 16 meters up to 135 meters. This state-of-the-art pumping station design utilizes 6 large volute pumps to achieve the flow with 5 duty and 1 standby pumps. The pump volutes will be manufactured in steel and will be further encased in reinforced concrete, to provide additional anchorage for the high forces which reduces vibration. Each pump will deliver 40 cubic meters per second to a dedicated rising main through non-return and isolation valves. Each rising main is protected from hydraulic surge by large 450 cubic meter surge vessels. These vessels, which are partially filled with water and compressed air, prevent sudden changes in pressure from occurring which could damage the pipeline. Due to the high flow in head, each pump requires a high-voltage 60 megawatts electric drive motor. As the pumps will run 24 hours a day, where every fraction of efficiency counts, the motors will be water-cooled from the suction flows, which will maximize motor efficiency and significantly reduce the cooling loads to the station cooling systems. To minimize the starting loads and optimize the electrical systems, a bypass recirculating line is provided to reduce the hydraulic load while each pump accelerates to the duty speed. A sophisticated bus main system allows the standby pump to deliver to any of the 5 rising mains, which will ensure high availability of the full 200 cubic meters per second pumping station design capacity. The simplicity of the pumping station layout is conducive to ease of access for operation and maintenance. The proposed design of the electrical systems prioritizes reliability, availability, and easy maintenance of the pumping station. The 300 megawatts power demand of the pumping station will be met by a new connection to the Egyptian national grid. A new open switchyard will be constructed adjacent to the pumping station building to receive power from the grid. The dual circuit connections are fully rated and have a cross connection to ensure that there is no loss of pumping capability, even in the event of maintenance or repair. Primary distribution is achieved by 2 separate, fully rated indoor switchgear assemblies. Each pump has a dedicated transformer, switchgear, and control gear. This arrangement facilitates maintenance and eliminates the risk of a failure event impacting on more than one pump. Pump starting is implemented using a pair of static frequency converter units. From the pumping station, water is conveyed through 5 pressurized pipes, 4.7 kilometers long, 4 meters in diameter each, up to the periphery of the Sphinx International Airport. The mass of water moving in each of the pipes is equal 60,000 tons moving at 12 kilometers per hour. The transportation of these pipes to the sites is a challenge on its own. To lay these pipes, 1.6 million cubic meters shall be excavated. A headworks structure recovers the kinematic energy before delivering water in a 300-kilometer canal. More than 60 million cubic meters shall be moved, up to 1.5 million cubic meter of concrete to be used to line the canal. Soils are perfect, crops are outstanding, the speed of construction amazing, only ingredient now missing is the canal to feed it all. The President Abdel Fattah al-Sisi has committed in front of the parliament to implement the project before June 30, 2019.
من اللي بيتعمل انتوا ما شفتوهوش وما تعرفوش عنه حاجة خالص. أنا هقول حاجة كده 30/6/18 30/6/18 غير المليون ونص فدان اللي احنا بنتكلم عليهم دول هيكون بيتزرع على جنب 200,000 فدان. آخر 18 نص 19 يبقى مليون فدان. أنا ماليش دعوة.
The concept design and feasibility study are prepared by Atkins, for IFS Global.